Good afternoon. It is now the top of the hour. Welcome to the November Innovation Connect, hosted by the Department of the Air Force Chief Data and AI Office. My name is Colonel Maria McElroy, and I am the Air Reserve Component Advisor for CDAO, and I will be today's moderator. The purpose of Innovation Connect is to create a collaborative atmosphere for those working in the DoD to cross-pollinate ideas across organizations to enhance innovation and identify and solve problems related to research and development and scaling. We are excited today about this event and we are glad you are attending. Before we start, a few ground rules. One, please turn off your cameras and mute your mics unless you are presenting. Our speaker will give an overview of his topic, followed by a Q&A session. Please use the chat function to ask your questions throughout the presentation. Lieutenant Colonel Chapa will answer them at the conclusion of his presentation. Number two, please, someone has a hot mic. Chuck, thank you. Second, please keep your questions to the topics presented and refrain from asking media-related questions or advertisements of your company or organization. The questions will be read aloud immediately following the presentation. So, this month's Innovation Connect presenter is Lieutenant Colonel Joseph Chapa, the DAF CDAO Chief Responsible AI Ethics Officer and Special Competitive Studies Project Liaison. He will spotlight his role and what it means to be the first Chief Responsible AI Ethics Officer for the DAF, the ethical implications of implementing AI in the DAF, and the DAF CDAO goals to becoming a global leader in responsible AI. With that, it is my pleasure to introduce our speaker. He holds a PhD in philosophy from the University of Oxford. His areas of expertise include just war theory, military ethics, and the ethics of remote and autonomous weapons. His doctoral research investigates an individual right-based account of just war. Lieutenant Colonel Chapa, thank you for taking the time to attend today's theory. My bad. His areas of expertise include just war theory, military ethics, and the ethics of remote and autonomous weapons. His doctoral research investigates an individual right-based account of just war theory. He is a senior pilot with more than 1,400 pilot and instructor hours, many of which were flown in support of major U.S. combat and humanitarian operations. He currently serves as the Chief Responsible AI Ethics Officer and Special Competitive Studies Project Liaison for the Department of the Air Force Chief Data and AI Office. Lieutenant Colonel Chapa has brought tremendous value and service to the DoD, and we are excited to have him present at today's event. With that, Colonel Chapa, the floor is yours.
Thank you very much, ma'am. Thanks for having me. Thanks for the opportunity, and thank you all for taking time out of your day to talk about ethics and AI. If you would just give me a confirmation that you can see the screen, that would be great.
Copy.
Great, thank you very much. So as you heard, my name is Joe Chapa. I'm the Chief Responsible AI Ethics Officer. And I know that's a lot of syllables. We call it the CRAO position for short from that acronym. And really what that's signaling from the Department of the Air Force is that we're taking AI ethics seriously in the department. And the reason that I think it's worth emphasizing that is that you have probably heard about AI ethics from all different quarters. You've heard it from industry, you've probably heard it from academia, you've certainly heard it from OSD. And although that guidance is sort of coming from the top down through OSD, the Department of the Air Force is, in my humble opinion, leading the way on implementing the DoD's guidance to ensure that we're doing AI responsibly. And I'll say more about those specific words here in a minute. So the creation of this role back in January of this year was kind of a major step, the first major milestone in Department of the Air Force policy to emphasize ethics in AI. You have heard that I'm going to say a little bit about where we're going. So let me do that up front just to kind of clear the air on that. And then what I'd like to do over the next 30 minutes or so is try to show you why we need to take AI ethics seriously. Now, I know that might sound like something we don't need to spend too much time on. Of course, we care about ethics, but I mean specifically, what is it about this particular technology that raises novel ethical questions? And what are we going to do about it as a Department of the Air Force? So that's the intent for the next 30 minutes or so before I engage with you on your questions and comments. But a note about where we're headed in the Chief Data and AI Office here in the DAF. So we have been given strategic level time horizons, objectives with time horizons from General Olson, the Chief Data and AI Officer, to be AI ready by 2025 and AI competitive by 2027. And what that means is by 2025, we want to have set the conditions for success in AI across the department. And then we want to build on those conditions for success to develop specific AI-enabled capabilities by 2027. So there's a little bit of a two-step process here. It's a big organization. There's over 600,000 people in the Department of the Air Force. So sometimes this language is confusing because it makes it sound like we're going to wait to develop AI capabilities until 27. That's not the case at all. There are parts of the department that are developing AI capabilities right now today. But what we're concerned about is that we're not in a position to scale those developments, or better still, to use the resources, the investments that are going into some AI capabilities, and to get additional return on investment for those resources in other capabilities. And so what we in the CDAO are committed to do is provide the enterprise-wide conditions for success. And I'm talking about everything from infrastructure to workforce development to responsible AI, building strategic partnerships, all those things we need to do at scale, so that we can develop AI capabilities more quickly, more cheaply, and integrated more broadly into the department down the road. So that's where we're headed. With that, I'm going to dive in and start to talk about AI ethics. So before I get too far, there is a linguistic challenge that we need to address. There really are two linguistic challenges. Every time I talk about ethics and AI, every single time this comes up in conversation, we get hung up somewhere along the line on, well, what do I mean by AI? And it's a fair question, because you could ask 10 different professionals who work in the AI space and get 10 different answers to the question, what is AI? And part of the reason for that is because it's very clear that AI has gained additional attention over the last decade or so. I think that's obvious to everyone. But it's also the case that AI has been around a long time. The term has been around since 1955. Some people say the first AI spring, the first time that money and resources were being thrown into AI, was during the 1960s. There was a second AI spring in what's called handcrafted knowledge systems, or expert systems, in the 1980s and 90s. Those systems used if-then logic, so kind of traditional computing tools, but complicated trees of if-then logic to get to expert systems. So essentially, the developers would sit down with an expert, figure out, how do you make your decisions? Can we codify that decision tree with if-then logic, and then employ a fairly complex handcrafted knowledge system or expert system? And now we're in the third AI spring. So starting in about 2010, something happened to cause additional attention and resources to be thrown into artificial intelligence for a third time. And the way that most theorists, most commentators describe that is really three things happen at once. First, there was the ubiquity of data. So you had organizations like Facebook or Amazon that have such regular interactions with you and me through our computers and phones that they're able to collect massive amounts of data, more data than any company was able to collect on individual people in the past. And so with that data, they're able to do things that they weren't able to do before. But there was another development that happened in parallel, and that makes it possible to get the developments we've seen in AI in the last 10 years, and that was developments in computing. So I'm sure you're familiar with Moore's Law. Moore's Law has been around for a long time, and it says that every 18 months, the computing power in a fixed size, the computing power per unit volume, doubles. And that's why we've had such advancements in computing technology all the way back since the 1970s and 80s. Okay, so that was true. Moore's Law was continuing, but the development really came in recognizing that there are a different family of chips, computer chips, that are more effective at machine learning than our traditional CPUs, or central processing units. And those are graphic processing units, GPUs. And really those came about through the gaming industry, right? So I don't have a GPU most likely in a 2010 era MacBook, but you probably would have a GPU in a 2010 era Xbox. And so when machine learning developers realized that they could get better performance, meaning they could train more sophisticated models using GPUs, and sometimes GPUs in combination with CPUs, that was a turning point in the computing power required to produce machine learning. So that plus data gave us more sophisticated models. And so those three things combined, ubiquity of data, new techniques in computing power, and with those powers combined, the ability to create more sophisticated models, that's what enabled the third wave in AI, or the third AI spring. And really that was around machine learning. So I know that there are people who will die on the hill that says AI includes both machine learning and legacy systems like handcrafted knowledge systems or expert systems. I agree with that completely. That's why I have this Venn diagram the way it is. Machine learning is a subset of artificial intelligence. But at the same time, we have to recognize that something happened around 2010, which, by the way, corresponded with this tremendous increase in concerns about AI ethics. If you're interested, you can go look these terms up on Google Ngram, and you can see the different waves in artificial intelligence with respect to how often people are using those words. And those waves correspond. The second wave in the 80s and 90s corresponds with expert systems. And the third wave, the wave we're in now, corresponds with AI ethics. So AI ethics really wasn't a concern before 2010. The literature on AI ethics prior to that was really about the ethics of robotics, which is pretty different. And I can say more about that in the Q&A if you like. This has been a very long-winded way of saying, in the CDAO office, we care about AI writ large, that big bubble. But when it comes to ethics, I want to focus on machine learning, because machine learning is the technological development in this century that has caused us to ask novel ethical questions. Deep learning is a subset of machine learning, and that just it doesn't refer to deep thinking. It just refers to the depth of the neural net, how complicated the neural net is that enables the machine learning. Okay, that's linguistic challenge number one. So now you know that when I say AI, I mean all AI. But when I talk about ethics, I am focused on machine learning. The second linguistic challenge is around responsible AI. I am sure you've heard this term thrown around in the DoD. There's a history here that I think is worth talking about. So in 2020, the DoD commissioned the Defense Innovation Board, the DIB, to come up with ethical principles for AI. And the DIB came up with 5 ethical principles. Our AI applications in the DoD need to be responsible, equitable, traceable, reliable, and governable. They wrote a report, defined those 5 principles, handed that to OSD, and OSD adopted them. So those became the DoD's AI ethics principles in 2020. So in 2020, the formal language was the language of ethics. In 2021, what was then called the Joint AI Center thought, we might not want to hit this ethics language too aggressively, because people in government, when they hear ethics, they tend to think compliance. They tend to think in terms of a checklist. And just to validate this point, when I had my first meeting with a senior leader boss, when I got to the Pentagon, not this organization, I was in a different organization, and he shall remain nameless. I was coming into work in the AI space, and I said, I'm just really interested to see where the ethics ends up applying in this job. And he said, oh, ethics is easy. For instance, I have a friend who's a retired wing commander. He now works at Raytheon. He offered to take me to dinner last night, but I didn't let him buy the steak. I bought my own steak. Right? So when I said ethics, he was thinking things like the joint ethics regulation that governs what gifts we can accept from contractors. So the Jake was worried that if we just say AI ethics, people are going to think, well, all we need to do is add some language to the joint ethics reg. People can go in and mark off the checklist and we'll be good to go. But as you'll see, I hope, these challenges are a lot more complicated than that. So the Jake said, let's not call it ethical AI. Let's call it responsible AI, to signal that we care about a whole lot more than just what's compliance-based. Now, we have some confusion here, because remember that first AI ethical principle is responsible. And now we're equating responsible AI with ethical AI. So we're painting ourselves into a corner here a little bit on the terminology. And then since then, Secretary of Defense Austin has said responsible AI is the only AI that we do. And if you read that one way, it makes it look like, hey, problem solved. We cracked the nut. We figured out how to do it. All of our AI is responsible AI. Well, I interpret that differently. I interpret that to say that the Secretary of Defense is giving us a mandate. He's saying that thou shalt, when you produce AI, thou shalt produce it responsibly, employ it responsibly, develop it responsibly, et cetera. So when I talk about AI ethics, I'm using those terms synonymously. AI ethics and responsible AI to me are the same thing, even though the DoD has chosen to use responsible AI for its guidance from 21 and following. Okay, that's enough table setting on the language. Now you know how I use the terms. There's still a little more that we need to talk about, though, because I think often in the DAF or in the DoD, when we talk about AI ethics, without realizing it sometimes, we slide into a conversation about the ethics of autonomous systems, or in our case, the ethics of autonomous weapons, because we're in the weapons business here in the DoD. And I think that's unfortunate, because I think there are a lot of questions we need to address in the ethics of AI, ethics of machine learning, that are independent from questions of autonomy. So let's just talk through that very briefly. There are autonomous weapon systems that have nothing to do with machine learning. The Navy's Phalanx close-in weapon system is one example. You can turn it in autonomous mode, and if it identifies an object that has a certain signature using entirely if-then logic, if it's at a certain altitude, if it has a certain bearing, if it has a certain range, then it will shoot it down. So it's if-then logic. You could think of it as an expert system. It's not ML, but it is autonomous. It has a fully autonomous mode. Likewise, you could think about machine learning that has nothing to do with autonomous systems. So if we create a machine learning computer vision algorithm that helps a human analyst to recognize certain objects in an image, but the machine isn't going to do anything with that information, it's going to just provide that information to a human user, most people would say, well, that's not autonomy, but it is machine learning. And I recognize that there's some overlap here. In the civilian world, you could think about a Tesla in fully autonomous mode. That is an autonomous system that is relying on even several hundred machine learning algorithms. So in the future, we will almost certainly have autonomous systems in the Department of the Air Force that rely on machine learning. And so those questions will come together in one system, but conceptually, I want to keep those questions separate to make sure that we're asking the right questions at the right times. This is the only slide I'm going to show you on autonomy, and then I really want to shift gears and talk about the ethics of artificial intelligence, independent of concerns about autonomy. So if you start with me at the top left of the screen, once again, the language is difficult here. Oftentimes, people want to talk in terms of autonomous systems, and I think that's a little bit problematic. So imagine that I create an airplane, and the airplane has an auto takeoff and land capability. It lands completely autonomously. Suppose, in fact, it lands completely autonomously without a human on the loop. The pilot is in the back of the airplane taking a nap. Well, then when it goes and flies its route, suppose it has a combat mission where it's going to release a weapon somewhere, and there's no autonomy there. That's a human pilot doing human pilot stuff, releasing that weapon. When I look at that system on the whole, I don't know whether I should call it an autonomous system or not, because it's autonomous in the landing phase, but it's not autonomous in the mission phase. And so I think it's more helpful to talk in terms of tasks the system can perform autonomously. So the relationship isn't between autonomy and system, it's between autonomy and the task we're asking that system to perform. So I have their sensing, decision aids, and automation. I'm sure we could come up with a dozen other applications of AI, but those are meant to show that I can use AI to shrink my human OODA loop. I'm sure you're familiar with the observe, orient, decide, act loop that John Boyd gave us on human decision making. If our goal is to gain decision advantage, we want to make decisions faster than our adversary, then I want to shrink that OODA loop. Well, I can use AI to get me from, for instance, observe to orient. Maybe I have AI-enabled sensors. Or maybe I can use AI-enabled decision aids to get me from orient to decide. Or maybe I can use automation, AI-enabled automation to get me from decide to act. But if I start giving a wider spectrum of that loop over to a machine, now we're talking about autonomy. I might be asking that machine to conduct the decide and act steps of the OODA loop, for instance. So the wider that red part on that loop gets, the more complicated the task that I'm asking the system to perform. So as an example, if you follow me down to the bottom left of the screen, 1990s era, Gulf War I era automation, an AMRAAM, right? An AMRAAM is a fire and forget weapon. It has its own guidance system. It has its own radar. The human pilot will conduct most of the kill chain, him or herself, find, fix, track, target, and then once he or she releases the weapon will do the engagement. It'll do the geometry, it'll do the physics, it'll take over completely, and the pilot can turn cold, as it's called, right? Can turn away from the engagement. And then I probably need the pilot to assess whether that weapon hit the target. So I'm only asking the automated system here, the AMRAAM, to conduct a very small segment of the kill chain autonomously. If you look at the bottom of that stack, the thing that people are worried about in a lot of the literature on autonomous weapons is killer robots. Right? Well, killer robots assumes that I'm giving the entire kill chain, the entire mission, everything about it over to the machine. I think in the near term, what you would expect to see in the DAF is wider parts of that spectrum being tasked to machines without tasking the entire thing. So maybe I have a human that does the find and fix steps. Maybe I have the machine do track, target, and engage, and then maybe I have the pilot do assess, just for instance. So a lot of the concern about autonomous systems can be captured in language such as the language used by the campaign to ban killer robots. We need to make sure these machines have meaningful human control. Or in the old Air Force UAV flight plan, we need to make sure we have humans in the loop, on the loop, or out of the loop at the right in the right contexts. Or in the DoD's language in 3000.09, which covers autonomy and weapon systems, we need to have appropriate levels of human judgment, right? These are the kinds of words you should expect if we're talking about asking a machine to perform certain tasks. I'll save contingent and intrinsic concerns for the Q&A. You can raise that if you like. Okay, turning a corner, we're putting autonomy to the side and we're focusing on AI ethics. This is just one way to think about AI ethics. And remember, when I say AI ethics, I want to focus on machine learning ethics. We could think about machine learning as a means of providing goat path solutions. If that's a term that's not familiar with you, as far as I can tell, familiar to you, as far as I can tell, it goes back to the Spartans at Thermopylae. You'll recall that the Spartans are about to battle the Persians. And the Spartans might have a chance. They know they're pretty sure they're going to lose, but they can at least hold the position long enough that the rest of the Spartans can tactically retreat. But there's a traitor among them, and the traitor tells the Persians how to get around the mountain. So the Persians take up a position in front and behind the Spartans, and the rest is history. Well, how does that human find the path around the mountain? He followed the goats. It was a goat path. So no human, no Spartan found the path, no Persian found the path. It was the goats. It was some combination of goat brains and goat hunger and goat instinct. And that's important because the goat path was incredibly, it was crucial to the history of this battle. It was very, very important. And the goat was able to do something no human was able to do. And yet we're not willing to say that the goat is smarter than the humans, or that the goat is a better tactician than the Spartans, or that the goat is a better strategist than the Persians. Instead, we just want to say in this very narrow task, the goat was able to do something the humans were not able to do. That's the way, that's at least one way to think about machine learning. In narrow tasks, machine learning is able to do some things to find some insights in the data that the humans are not able to find. Okay, so let's look at kind of the risk that comes about in these machine learning goat path solutions. I'm going to give you a 5-step process for how to train and test a machine learning model. And then I want to try to highlight for you where in that process we should be a little nervous, where we should give it a second look to see what kinds of things might come out of the goat path solutions that we don't want, right? Because that's the risk, is that the goats can give us an answer that we need, that we didn't expect. But because they're going to give us answers we don't expect, sometimes they can give us surprisingly bad answers. Okay, so the first thing I need to do, I'm talking just about supervised machine learning here. There are other techniques we can talk about in the Q&A, but supervised learning is the most relevant right now in the DAF and in the DoD. So the first thing I need to do is collect the data. I need to curate the data. I need to make sure I have the right data, and it has to be labeled data. In this sense, it's supervised machine learning. I'm going to provide the machine both with the raw data and with the label. So just as a notional example, let's say I want to train this model to be able to identify pictures with puppies in them. Well, I need to give the machine not just a bunch of pictures, some of which have puppies in them, but I also need human labels that say puppy, no puppy, puppy, no puppy, because it needs to learn how to recognize which patterns of pixels are correlated with those labels. So in the training phase, I'm going to take some of that data, not all of it, because I need to save some of it for test and evaluation. But let's say I take 60% of that data and I train the model on that data. I'm giving the model both the images and the labels and saying, all right, model, you figure out which patterns of pixels are most tightly correlated with the label puppy and the label not puppy. The next step is the feature extraction step. This is where the model is determining which variables are correlated with the label. So it's identifying patterns of pixels here. Those features, those 6 features I have there, are patterns of pixels, some of which are associated with the label puppy and some of which are associated with the label not puppy. Now, remember, I saved some of that data, and now I need to do some test and evaluation. And there's something crucial that you need to understand here. If the problem that I had with my model, I'll talk about several problems here in a minute, but if the problem that I had with my model is that I didn't start with the initial data set that was sufficient to reflect the real world, if there was something wrong with my initial data set, then whatever that problem was in the training phase is going to persist in the testing phase, because I don't have any data other than the data I started with. So when I take 60% of that initial data set to train the model, and then I take, let's say, 20% to test the model, if the problem was limitations in the data, then the testing phase here is not going to solve those problems. It's not going to be able to identify those problems. Then finally, I deploy it in the real world. It now experiences real world data for the first time, and hopefully it gives me the labels that I would expect from a human. So the whole idea here is it's not actually learning what puppies are. It's just learning to recognize correlations in the data, or rather patterns in the data that correlate with the labels, and then it's trying to predict what a human labeler would do. Okay, there are lots of ways you can categorize problems with AI, challenges in AI, risks with AI. I'm using something from Georgetown CSET. They have a series of papers on AI safety, and they bin them in the following way: failures of robustness, failures of specification, and then failures of assurance. I'm going to focus on robustness, but we can talk about the other two later on if you like. So failures of robustness really are focused on that data phase in step one. Does your data sufficiently reflect the real world? And we'll talk about what that means here with some examples. So it's a real world example in the sense that this actually happened, but it happened in an academic environment. Researchers from University of Virginia and University of Washington used a well-known training data set called in situ, 125,000 images. All those images have been labeled across the five axes that you see there at the bottom by humans. Then they trained a model to do computer vision to be able to predict what would the human labelers come up with in each image. So they used about 60% of the data to train the model. Then they used about 20% to test the model. And when they tested the model, they were surprised to find that the majority of the time, when there was a picture of a man standing in a kitchen, the machine spit out the label kitchen and woman rather than man. So they took a look at that and said, well, that's interesting. Let's go figure out why that might be the case. So the first thing they asked was, is there a bias in the initial training data set? And the answer was yes. There was a bias of about 70% to 30%. That is, of all the pictures of kitchens in the training data set, 70% of the time, the agent was labeled as a woman, and 30% of the time, the agent was labeled as a man. But in the outcome, the bias gets worse. So in the training data, the relationship there is 70 to 30. In the output, the relationship is 86 to 14, 84 to 16. So 84% of the time, it says the person in the kitchen is a woman, whether it is or not. And 16% of the time, it says it's a man. So it's taking the bias from the training data and amplifying it, making it worse. So it's not just garbage in, garbage out. It's whatever the garbage is coming in is actually being amplified and made worse. Okay, now a couple questions here. You could say, okay, fine, but what does this have to do with ethics? And I would submit to you that it does have to do with ethics. If there's a stereotype about women in kitchens that is the thing that led to the data being biased in the first place, then this model potentially not only reproduces that stereotype, but amplifies the stereotype. And I will submit to you that there's ethical content there. Now, a couple things you could say. You could say, first of all, well, okay, fine, but we're in the business of breaking things and taking human life on the battlefield. And so the ethics we're concerned with, this kind of pales in comparison to that. So I will say, first of all, hold that thought, because I'm going to come back to that in a few slides. But second of all, realize that we also have personnel systems in the DAF. We also have medical systems. We also have finance systems. And so anything that's happening in AI ethics in industry that's concerned with things like race or gender bias or LGBTQ bias, those things are going to come up in our systems also. Just go ahead and do this thought experiment with me if you want. Imagine our historical promotion data over, let's say, the last 30 or 40 years. We probably have that data. It's labeled data in the sense that we have the personnel records and we also know who was promoted. I would bet you, historically speaking, objectively speaking, that data is biased toward white men. We can fight about that if you want. That data is actually published historically, so you can go look that it is in fact objectively biased toward white men. So if there's a bias in industry AI that is concerned with, let's say, gender, then we absolutely have to care about that in the DAF. Because if we were to employ a machine learning tool that's trained based on our historical promotion data, I can predict for you what biases are going to be in that outcome because there are biases in the data. Okay, so that's the first thing. Yes, we have to care about those things because we have systems that touch people data also. But what I really want to do is show you that the technical limitations that result in a bias like this also can apply in the warfighting environment. It's just going to manifest in different ways. Okay, I'm going to back up. In fact, I'm going to back up a lot. Let's back up about 2,500 years. This is the School of Athens. It's Raphael's painting from 1511. It depicts many of the major thinkers throughout history up to that point. But right at the center, we have Plato and Aristotle. Plato is the elderly fellow, and Aristotle is his student, the sprightly fellow on the right. Plato's pointing to the sky. Why? Because that's where the forms are. The things that are truly real, the really real things, are beyond the edge of the world. They're out there somewhere in Plato's heaven. And so what they're really driving at here, both Plato and Aristotle have a conception of where we get our ideas from. If I ask you to picture a tree right now in your mind, I bet you could do it. It might look slightly different from the tree that I'm picturing, but I bet everybody on the call right now can picture a tree, and they're going to be somewhat similar because we all know what trees are, right? The question Plato and Aristotle are trying to answer is, where does that idea come from? And Plato says it comes from out there somewhere. And Aristotle says, no, it's in the thing itself. It's out there in the world. If you want to understand what a tree is, you have to empirically go study a tree. And so this is the birth of the idealists and the empiricists. And I'm happy to say more on that if you like. But the point I want to get to here is both the idealists and the empiricists agree that there is such a thing as a form. There is such a thing as an idea of a tree, and you and I all have it. We have an idea in our mind of what a car is. We have an idea in our mind of what a house is, right? We have really a robust mental model of the universe that we live in. And what I want to submit to you is that machine learning does not have that. So I don't know if we can actually be interactive here. Let me see if I can open up the chat. Someone put in the chat, give me something that all insects have.
Hold on, Joe. Are you finished? Otherwise,
No.
I'm going to go ahead. So do you want to take some intermittent questions?
Just
So I'll read them all.
one question. Just this one question. Someone put in the chat, what do all insects have in common? 6 legs. I saw 6 legs. Sometimes people say 3 body parts, right? 3 body parts, 6 legs. Agreed. 6 legs. So answer me this then. You don't have to do this in the chat, but just to yourself. What about this little guy? Is this little guy an insect? It's a caterpillar if you can't see from the image. It is an insect, right? It is a caterpillar is an insect. Why? Because he's going to make a chrysalis and then he's going to emerge as a beautiful butterfly. And the butterfly has 6 legs. The caterpillar does not. And we're okay with that, right? Because when we said a moment ago that all insects have 6 legs, what we really meant is that all adult insects have 6 legs. And this is just a baby insect, right? It's the pupal stage of the insect. And our mental model is sufficient to account for that. Now, here's the question. Does machine learning possibly come up with a mental model of what it means to be an insect? The answer is no. But it can, if given enough data, it can recognize that the pupal stage of this insect is correlated with a particular species. There's an app called Seek. I have it on my phone. My son loves it. And I took this picture of this caterpillar, and I don't know if it's accurate or not, but it uses this machine learning algorithm against the data it's already been provided to predict that this caterpillar is this kind of insect. Okay, so machine learning is not going to have a mental model of the universe. That's why the goat path solutions can be dangerous, because they're not going to give us the same kind of thought that a human analyst would give us. But they can find insights in the data, and that's what's valuable about machine learning. I'm going to skip this case for the sake of time because I want to hear from you, but let me give you two more cases to show how this ethics conversation, how the technological limitations that lead to things like race and gender bias can affect us in the battle space in the data. So recall the 5 steps. I'm going to go through those 5 steps again, but in 2 different cases. This is a real world case from about 2015. Recall that Amazon was building its recommender engine right at the beginning of the Amazon recommender engine. It was really dumb, right? I bought a garbage disposal for my house, and Amazon's recommender said, "Oh, it looks like you would like to buy a garbage disposal." Well, no, I just bought one of those. I don't need another one, right? So I didn't click on it. And by not clicking on it, I'm giving Amazon data on what I might actually be interested in. So over time, they started to refine that. They got really good at it. And then they looked around their company and said, you know, what else do we have sufficient data for that we could use machine learning to come up with solutions? And they looked at the HR department and said, well, we have 10 years worth of hiring data. And it's structured data, so we can do supervised machine learning. Why? Because we have not only the resumes we received, but we also know who was offered a job. So that's the label. I have those who are offered a job, those who are not offered a job, X and not X. So I've got the raw data and I've got the labels. So they ran it through the training. They ran the model through the training process. They extracted features. Now at this point, the developers don't know what those features are. So I'm going to hold off on that for a second. Then they tested it. The testing went okay, except they realized, just as the in situ researchers did, that their model never once recommended a woman for a job. It recommended only men for a job. And so they said, well, that's interesting. Let's go look at the feature extraction step and see what features it learned to correlate with the label got the job or was offered a job. Now I'm speeding here a little bit because these are actually 2 different cases. So first look at that bottom case, not hired women's. This is from the Amazon case. They found that the possessive word women's was penalized by the machine learning model. So it learned that if you have a phrase like women's college or women's engineering organization or captain of the women's tennis team, then the model learned to dock points essentially from those resumes because it correlated the possessive word women's with the label not hired. So they ended up scrapping the program. They didn't go to fielding with it because they couldn't figure out a way to solve that problem with the data that they had. There was a different case. The name of the company is unknown to me, but it came up in one of the interviews where a company was pitching their HR tool, machine learning tool, to a company. And when they went to evaluate it, they found that one of the features that this thing learned to associate with the label got the job was lacrosse, and another was Jared. So for reasons unexplainable to the developers, if you were a person named Jared who played lacrosse, you had a high correlation with the label got hired. So this is a kind of classic industry case that results in gender discrimination. What does that have to do with us in the DAF? Here it comes. I wish I had a real world use case I can give you, but we're kind of at the vanguard of this stuff in the DAF. So we're just not there with operational examples, but we can come up with a pretty plausible notional example that drives the message home that the technological limitations that result in race and gender bias issues in industry, they map on to our use cases in the DAF. They're just going to manifest themselves a little differently. So let's imagine that I want an autonomous target recognition algorithm based on machine learning computer vision. So I want to use imagery to be able to identify targets. Let's imagine that's a plausible use case for us, I would think. So I start with my data set. I want my data set to include Chinese J20s because that's what I want to be able to identify. And I want to be able to distinguish them from F-35s, right? Our 5th gen fighter from their 5th gen fighter. That seems like a pretty reasonable thing to do. So I make sure that my data set has J20s and F-35s. I train the model. I go to the feature extraction phase, which realize the developers can't see that yet. So I'll come back to that. Then we go to the testing phase, withhold the labels, run our algorithm on the new data that it hasn't seen yet, and then I compare whatever it spit out to whatever my known human labels are. That's how we do the testing. And then ultimately we field it on real world data. Now, here's the challenge. When we do the feature extraction step, we don't know what features the system is identifying as valuable, which features are tightly correlated with the labels. And it's plausible, it's possible that in a case like this, the thing that the machine learning algorithm learns to recognize is sharp angles at the front edge of the fuselage of the airplane. On the J20, those are canards. Those are those little winglets that are up in front of the main wing that help with flight control. Well, I don't have any airplanes in the United States Air Force that have canards on the front of the airplane, but some of my friends do. Right? So we can imagine going through this entire process through step 4 and saying, look at that. I tested my model and it performed extremely well against all US Air Force, US Navy fighter aircraft. And then we think we're ready to go to war. And when we go to war with the Brits alongside us, as we almost certainly will, the Brits are flying not only the F-35, but also the Eurofighter Typhoon, which has, you guessed it, canards at the front of the airplane. Right? So the same kind of error, the same kind of technical limitation that led me to bias in the earlier industry cases, where the output was bias about race, gender, et cetera. In our context, the exact same phenomenon can apply, but it's going to manifest itself not in race and gender issues, but in me picking the wrong targets. And I would submit to you as a military ethicist, that is an ethical concern. The ability for us to distinguish between adversaries and allies and partnered systems, that's incredibly important to us both operationally and morally speaking. So all that to say, when we think about AI ethics, it is important to think about the use cases that we're getting from industry. Those are best practices we can adopt. But when we apply that discussion internal to the DAF, we have to think about at least two different areas. We have to think about the way that it's going to apply in our own business practices, our own personnel systems, medical systems, finance systems, right? That maps on really well to the industry cases. But we also have to think about how those same technical limitations might manifest themselves in operational mission systems. And I don't just want to think about autonomous weapons. Sure, that's a place we need to be concerned, but imagine that I ran that targeting algorithm on board a traditionally piloted F-35. We can't convince ourselves, we shouldn't convince ourselves that the only place this applies is in autonomous weapons. If I run that kind of system on a traditionally piloted F-35, I still am in a position where I might shoot down the wrong airplanes. And that's bad, both morally and operationally. Okay, I went a little long, but I think we have plenty of time for discussion. I'm going to stop there.
All right, thank you for that, sir. We have currently 3 questions that are in the chat box, and I will start with the first one that comes from Rhonda Mouse. And she states, in reference to your autonomy slide number 4, is this distinction being made in the new 3000.09?
So the last draft of the new 3000.09 I saw, which was several days ago, it distinguished between autonomy and ethics, but between autonomy and AI, but its reference to AI just rehearsed the AI ethical principles. So what it does do, which the old version did not do, is it at least rolls in the AI ethics principles under 3000.09. So presumably If you had an autonomous weapon system that triggers the review described in 3000.09, that review now would have to also ask, have you submitted to the 5 AI ethics principles, whereas the previous version didn't do that. So I think that's a step in the right direction, but I think the way the principles are defined is a little, lacks a little bit of rigor. And so, under traceable, for example, I can imagine a contractor saying, well, sure, it's traceable, defined in the following way, which may or may not fit under people's interpretation of the traceability principle in the AI ethics principles. So all that to say, I think it's a step in the right direction, but I don't know that it gets us all the way there as far as using 3000.09 to ensure compliance with the AI ethics principles. Does that answer the question?
I'm going to wait for her reply. But in the meantime, our second question comes from Matt Beyer, and he states, which CDAO activities or programs are supporting responsible AI or moving us closer to that standard? Also,
yeah, so
could you
go ahead.
Go ahead, and I'll give you the second part. Go ahead and answer that one.
Yeah, so what we're trying not to do is we don't want the CDAO, the DAF CDAO, and I'll just admit here that I'm speaking for myself, right? This is my understanding from working in the organization. I don't have the authority to actually make these decisions. But my sense is the CDAO doesn't want to be the owner of individual AI-enabled programs. Those should be out at, the SPOs, at LCMC, being developed by AFRL, the accelerator, and some other places. So we don't want to own those programs. What we do want to do is make sure that we're establishing, like I said before, those enterprise-wide conditions for success. So in responsible AI, what that means is integrating as tightly as we can with the responsible AI team in the DoD CDAO, the Chief Digital and AI Office. That's the follow-on organization to the Joint AI Center. So they published their responsible AI strategy and implementation pathways document in June. There are 64 lines of effort in there. 23 of those belong to us. We're the OPR for 23 of those. So our job there is to kind of be the lead cat herder across all the stakeholders who need to get involved to make sure that we execute those 23 lines of effort on responsible AI. So it's not a program as much as it is an approach and ultimately a set of policies. So I will say what we'd like to do is publish responsible AI policy that enables us to ensure that we're meeting the intent of the AI ethics principles and that pathways document I mentioned, but without slowing down innovation. And that's hard to do. So one of the first steps we need to take is conduct the AI inventory, which is to say we need to figure out what AI programs are out there. And this CDAO this year, previously that effort belonged somewhere else in the JAIC. They've moved it into the responsible AI realm because it's important for us to be able to say, hey, we're doing responsible AI correctly. Well, we got to know what we're doing in AI. And so that is one program that AI inventory that's moved into the responsible AI team to make sure that we have visibility on what's going on in AI across the DAF.
Okay, Colonel Chapa, to follow up with that, Rachel Ramirez asks, how do you ensure everyone is doing responsible AI, or what do we do next?
That's a really hard question, and I think if we knew the answer to that right now, then we wouldn't need a responsible AI team in the CDAO. So that's something that we need to figure out. I will say I agree with you that asking the question, how do I build this AI thing responsibly, is much easier to answer than how do I ensure everyone in a large and complex organization is doing AI responsibly. So the short answer is I don't know. The longer answer is we need to figure that out. But there's going to be some. So first of all, let me say we are aware of the organizations that are doing AI right now, and they're all taking AI ethics and responsible AI seriously. So it's not like there's a bunch of rogue actors out there in the DAF that are trying to do AI on the cheap, trying to do it fast, trying to cut corners. The people who are doing this are experts in the field and understand all this stuff that I'm talking about AI ethics. I will say one concern that I have is that as AI becomes more ubiquitous and cheaper, there are going to be a lot of industry partners that want to sell us AI-enabled tools. And I don't think right now we have a sufficiently robust mechanism to evaluate those incoming, COTS or just commercially developed AI tools to say, hey, have you, throughout the development process, throughout the life cycle, have you followed the AI principles? So we need to partner with our teammates in AQ and SQ to make sure that we come up with the right mechanism for ensuring that. And we're just not there yet. That's a good question.
All right, to finish this out, does every ML need interpretable features?
Great question. So the interpretability question, you might call it explainability. The DoD principle is traceability. The reason that comes about is because, as I mentioned, deep learning is a subset of machine learning. And so the more layers you put in the neural network, the more it becomes the case that you can't trace back the output to the input. In other words, you can't define the causal analysis that got you from input to output. And so that's what people mean when they talk about black box AI, that I just don't know how it came up with the answer it came up with. And my answer to that, this is just my opinion, but what I would like to do is have a context relevant answer to that question, right? So suppose I wanted to develop a machine learning algorithm to help me pick my socks out in the morning. The consequence for failure in that environment is so low that I'm perfectly willing to accept a non-explainable solution. When we start talking about people data, right, medical diagnoses, promotions, and certainly when we start talking about kinetics, the consequence for failure in those situations is extremely high. And so that's a place where I think we really would want to tighten our acceptable level of risk and say, look, even if you have the latest, greatest, high-performing machine learning tool, if it's not explainable, if you can't tell me how we got from input to output, then I, as a commander, I wouldn't want to take the risk of employing that system. So I don't have a formal answer, but my instinct on this is that we should have a sliding scale for accepting explainability concerns depending on the consequence for failure in the context.
Okay, sir. Earlier you had mentioned a Navy system that is not AI, but is an autonomous system. What's its name?
It's called two things. It's called the phalanx. That's like it's like we call things Eagle and Viper and Raptor. The other term for it is the close-in weapons system, or CIWS. People call it CWIS because they tend to invert the I and the W. And it's been around for probably 20 years or so.
Copy. Thank you for that. So the next question comes from Mr. Normal Burke. He said, you talk about difficulties with conflating autonomy and AI when it comes to ethics. Do you have a go-to example of autonomy that isn't AI to help people think of them as separate topics? For example, I have used an argument that thermostats are technically autonomous, but it isn't a very satisfactory example for some people.
That's right. Yeah. So I have a friend in Space Force named Aaron Salaya, and he's got a paper and then a briefing that he gives where he talks about this spectrum of automation. And I think that's a helpful way to think about it, right? So at the very rudimentary place, you could say like a toaster, right? That's not even a thermostat. Well, I guess it is a thermostat because I can set how dark I want my toast, right? But that is just one if-then logic question. I set it to whatever I set it to. When the temperature reaches that level, it pops the toast up, right? That's automation, but most people would say it's not autonomy, right? And so the difference between simple automation and autonomy, according to Salaya's framework, which I think is a good one, is the complexity, right? So as you increase the complexity of what you're asking the machine to do, at some point, which maybe we don't have defined very well, you cross that line from saying not only is it automation, but it's an autonomous system, or in my view, it's a system that performs a task autonomously. So I like the phalanx that I just mentioned. That's a real system. The Aegis cruiser is another Navy system that has a fully autonomous mode. People often want to talk about the time that a US Aegis cruiser shot down an Iranian airliner. That's not a great example because it wasn't in fully autonomous mode, but it does have a fully autonomous mode that suggests, that if you have a certain projectile like a missile, that it could track that missile and engage it automatically. So those are some examples. I like to use the AMRAAM as an autonomous weapon case that's not machine learning and not modern AI, as long as you consider the autonomy starting after the pilot pickles the weapon, right? So as soon as the weapon comes off the rail, it is now a fully autonomous system. You can't call it back. It takes over with its own radar. It provides the intercept, right? It's doing the geometry problem. And then when it gets within a certain range, it'll detonate automatically. So that's a fully autonomous weapon system. It just doesn't, the autonomy doesn't include the decision to shoot. The pilot makes that decision, and then the system becomes fully autonomous. I don't know how helpful those are, but hopefully that gives you a couple other options.
Okay, so this one's a little long, so bear with me. Rhonda Miles says, because AI is always software running on hardware with data, and because there is often a mix of AI and non-AI systems together in the software systems, how can we tell system acquirers to be ethical about AI or ML in your parlance, part of the system?
Yeah, that's a great question. So channeling my inner tester, I think if you talk to the test community, they would ask, what is the system under test? And those various levels that you mentioned, they all need to be tested at some point, right? So the machine learning algorithm just by itself, when I was talking about the testing phase, I was just talking about testing that algorithm against the test data that comes from that initial data set. It's probable that a contractor industry partner will do that test themselves. And then they'll do the integration step, which is what you mentioned when you embed that algorithm in the broader sort of piece of software that can actually run on the hardware that we have. And then if that goes into something like a weapon system, that whole thing also has to be tested. So those are at least 3 iterations that require, in the old days, we would have said both developmental test and operational test. At this point, those two, OT and DT, kind of collapse in the software world. And that's when we start talking about DevSecOps and things like that. But the question is, what is the system under test? And the answer has to be all of those things need to be tested at various places in the life cycle. And I think right now we're still at a place where we're trying to figure out what is the appropriate policy to ensure that in stuff that's coming from outside the DAF, not AFRL stuff that we're building ourselves, but stuff that we're getting from industry. How do we ensure that when it was tested to our standards? I think at the moment we don't have a good answer for that. Though I don't work in the test world, so I should say that just from my perspective, I haven't seen that yet. It's possible the test world has come up with that.
Okay, so to finish off, she said, given the maturity of computer science, isn't it time we apply these ethics to all software and the hardware it runs on? Shouldn't we be ethical about all of the data?
Yeah, absolutely. So let me say something about ethics in general, and then I'll say something about data. So obviously, as the ethics guy, I mean, I want us to be ethical about all of the decisions that we make. And I think some people have a reaction to me and the kind of things that I talk about to say, like, this is all kind of hype, right? Like every new technological development raises new questions. And that might be true, but that doesn't absolve us of our responsibility to answer those questions. And so what I'm trying to do in this talk and elsewhere is to point specifically at where are the vulnerabilities, where are the things that might inadvertently cause us to produce an outcome that has high ethical cost, right? That's ethically bad in a serious way. And so I only talked about robustness here. I could have talked about more, but I think it's important for us to figure out where those vulnerabilities are and then make sure that we're acting appropriately to defend against those unintended consequences. So yes, we should be ethical about everything, but here that requires specific, looking at specific technical parts of the development pipeline. As for data, I didn't say anything about ethics in data, but I absolutely agree with you that there are questions that data raises, right? So if I'm gonna produce some AI tool that requires me to collect people data, I'm taking on moral obligations to the people who were the generators of that data, right? So if we're gonna use medical records to develop AI tools to identify cancer early in MRIs, for instance, well, then absolutely we have obligations to safeguard that data, to make sure that we're not aggregating that data to learn things about people that they didn't want us to know, right? There are all kinds of implications that come with that. I didn't say anything about that in this talk, but I agree with you that those are questions that we absolutely need to take seriously. And the Chief Data and AI Office does take those seriously.
Okay, so we have 2 more. This one is coming from Chris K. He said, how would you summarize the points of AI ethics for the DAF? Does explicit focus on ethics actually add anything if the ethical risk overlaps with the risk to effectiveness introduced by failure of robustness, specification, and assurance?
Yeah, so let me try to repeat that question back, and then maybe you can contact me offline if I don't get it right. But I think the heart of the question is there a conflict between what I'm trying to get at with ethics and what we might be trying to get at with getting these systems to perform well, getting the job done, being able to employ the tools that we need to employ to win. I actually don't think there's as much of a tension there as most people do. And if you think about everything that I just described in this sort of process, right, it's true that if, let's just take the Amazon example, it's true that if they were to retroactively go back, get better data, retrain the model, it's true that the result would be less biased. And that matters from an ethics perspective. But it's also true that the model would be more accurate, right? Because generally these ethics failures are also operational failures, right? If you could take another example of, facial recognition. There was lots of literature on facial recognition where they didn't have sufficient data on dark-skinned faces. They only had, it's not that they didn't have any, but they didn't have enough. And so when they train their model learned to be really good at recognizing light-skinned faces, but really bad at recognizing dark-skinned faces. That's an ethical problem because it's an unjust distribution of goods and harms on racial lines, right? So that's an ethics concern. But if you were to go back and fix that model so that it does perform well on dark-skinned faces, not only do you address the ethical issue, but you also address the operational failure. And so the message I would like to drive in the DAF is that the kinds of things that we're worried about in combat, right? If we put the weapon on the wrong building, that's an ethical failure, but that's also an operational failure. It also means we didn't put the weapon on the right building. And so I think as we start to take AI ethics more and more seriously, and I don't mean that we're not taking it seriously now, but I mean as we start to actually figure out what are the right policies to make sure we're doing this right at scale, it's not only going to preempt ethical failures, I think it's also going to preempt operational failures, and that should be something that we all want to get behind.
Okay, and our final question comes from Bernie Bauer. With the DoD's responsible AI guidelines and procedures, what is the expectation that individual companies have their own policies and procedures?
Yeah, that's a great question. So I can't speak for the DoD, but if I were to try, I would suspect that the DoD is trying to craft policy that's kind of agnostic to the position of the company, because they have to, right? Because there's so many different companies that some might have ethical principles, some might not. And so the DoD is trying to build policies that will apply across the board. There are several big companies, kind of the defense industrial base that we normally think of. Several of those companies have already aligned themselves around the DoD's AI ethics principles. But I think we should just expect that we're going to get different things coming in the door. I think as we start to lean on startups and cybers and things like that more and more in the AI space, you're going to get people who have never dealt with the government before and might not even be aware that the DoD has these AI ethics principles. So the challenge for us in the DoD, but also in the DAF, is to figure out how do we create policies to interact with our industry partners that are able to handle companies that have given this a ton of thought, but also companies that haven't. And that's a really hard challenge to come up with the sort of the requirements to be able to test their system against standards in responsible AI. We're not there yet, but we have a mandate under that June document that I mentioned to try to come up with one.
Okay, that does it for all of our questions. One last go round. If there's any questions, well, I take it back. There's a question here. It says, JAC, prior to CDAO at least, is suggesting we include requirements to adhere to our RAI policies and demonstrate their own principal governance, et cetera, within the contract. Oh, that was an answer. I'm sorry. Thank you.
Okay.
Rhonda. That's it, sir. Thank you so much for your time. We really appreciate you taking out time of your day to share with us. And we thank each of you for attending today's program. With the support of our DoD innovators, Innovation Connect has become a success. Oh, I stand by one more question. You like to, Daniel, Ty, can you put it in the chat?
Yes, ma'am. I was actually going to send it to you now. The question is, what about misuse of tools? We probably have a lot of people misusing tools or not understanding the assumptions of models and therefore misinterpret the results. Given the consequences, could this be more drastic with AI, and how do we mitigate that? That's from Nirma Burke.
That's a great question. So I didn't talk about AI assurance, but that's really what AI assurance is about. Have we prepared the workforce well enough to interact with these AI-enabled systems to be able to recognize faults, to be able to mitigate risk? And that's a huge challenge. So as a former pilot, every time the Air Force lets me fly an airplane, they give me a big fat book called the -1. There's an emergency procedures section in there that I have to memorize. I memorize the notes, warnings, and cautions. And that's so that when I see lights and sounds, hear sounds in the cockpit, I can interpret what's happening under the hood, right? I use those inputs to be able to figure out what's wrong with the machine. We need to have that kind of equivalent, a -1 with an emergency procedures section for AI-enabled tools, and I don't think we know how to do that yet. So to put it another way, if I was to have an F-35 pilot that was controlling a swarm of 8 artificially intelligent systems that perform tasks autonomously, how much do I need to teach the F-35 pilot about how AI works to make her successful in mitigating risk? I don't know the answer, but that's something that we need to find out, which is why workforce development is a huge part of AI, but also of responsible AI.
Okay, thank you for that. I believe to finish that out, it followed up with says, given the consequences could be more drastic with AI, how do we mitigate that?
Yeah, again, I think it's a workforce development challenge. And the problem is it's one thing to say, I need my data scientists to go get a degree in data science. Actually, it's debatable whether that's even the case, right? But we might have ops researchers, 15 alphas, or maybe cyber folks in the 17 X-ray career fields where we have to give them extensive technical training for their jobs. The harder question is, what do we do with everybody else, right? I mentioned the pilot, but we're going to have AI-enabled logistics for just-in-time logistics delivery. How much do you have to teach a logistics operator or logistics officer to be able to employ those systems safely? I don't know yet, but that's something we need to figure out.
All right, so our final question from Rhonda Moss again. It says, does the Air Force have written guidelines yet that we can share with other services until more guidance comes out?
So the interim guidance that a lot of people are using. So first of all, we are now subject to the DoD's responsible AI strategy and implementation pathway that came out in June. So that's something you can share, although it's not a DAF document. There's the Defense Innovation Unit has a responsible AI guidebook that's really helpful. It's fairly short. It's a lot shorter than the DoD's document. So that's something that a lot of people look at as that's what people were using as interim guidance, although it wasn't authoritative before the DoD document came out. And then if you're interested, the DAF MIT Accelerator published a document called the AI Acquisition Guidebook last year. And there's two things in there. One is it recounts the AI ethics principles. So that's, it's an Air Force document, but it's got the AI ethics principles in there. But they also outline all the guidance that we're under in the various NDAAs, executive orders, and other strategic guidance. So that's a good kind of one-stop shop. There's several pages of information on there on what guidance we are subjected to that's coming from outside the DAF. But that's the best answer I can give you at the moment.
All right, everyone, that concludes all of our questions. Thank you for taking the time to attend today's program. With the support of our DoD innovators, the Innovation Connect has become a success, and we look forward to spotlighting more innovative projects in the future. Approved videos of our Innovation Connect events are available on the DAF CDAO YouTube page. If you have a future topic for Innovation Connect, please send your recommendations to Ms. Ty Daniel, and our team will review your proposal. Also, please follow us on LinkedIn and Twitter accounts for future events and registration information. This concludes our Innovation Connect. Our next Innovation Connect is scheduled for 8 December with a special presentation from Red Force on the Air Force's effort to use AI to improve intelligence gathering. Thank you again for your participation. See you next month.